Hi everyone, in this video we are going to talk about data collection and the 4 methods of sampling. So you've heard different examples of statistics your whole life, and you may have used some of them to even inform decisions. Perhaps you tried to simplify your life or declutter your room when you read that the average US house has 300,000 things in it, but we also only use about 20% of the things we own. Perhaps you've tried to cut back on your cell phone usage because you read a statistic that teens who spend 5 hours a day on their phone are more likely to exhibit suicide risk factors like depression or substance abuse. Or perhaps you've just gotten a kick out of some other statistics like that you're more likely to be killed by a vending machine than win the Powerball lottery. Or that of those that do win the lottery, 70% go broke within 7 years. So, whether the statistics you've heard have affected your life yet or not, they have all started with data collected by some method of sampling. So, it's important to note here that no matter how sampling is done, all of these methods you see could have some degree of error or bias. So, it's best to use probability thinking when considering the sample method. So, we tend to prefer these methods on the left side because they're based on probability. All right, so these are going to be our 4 random sampling techniques, right? And even though one of these top left is called random, all 4 of these are actually random. Some just get more specific than others. All right, notice that all of these groups have 15 people with 5 or 6 being circled, randomly selected in different ways, right? And remember, we want that randomness to avoid bias as best we can. Right, so our goal is random, that each subject in the population has an equally likely chance of being selected. All right, so we're going to start top left with that simple random sample, right? This is kind of like picking names out of a hat. In this group, it looks like person 1, 4, 8, 9, and 11 were selected. And typically, you're going to have a computer or even your TI Inspire calculators can randomly generate numbers. Right now, with the next 3, we're going to get more specific. All right, so with the systematic sample, this would be like if you were in a factory and your job is checking every 10th item for defects. If you're a senior going to prom, the administrators might be breathalyzing every 5th student that comes into the building. Suppose you had the whole Lenape population. Let's just say there were 2,000 students. Well, if I wanted to have a sample of just 50 of them, I would divide the total 2,000 by 50, and I would end up getting 40. So that would be my K value if I were doing the systematic sample of the whole Lenape population. I would pick every 40th student to fill out a survey. And it does not necessarily have to start with the first person, right? Like in this picture, every 3rd person is selected. It does not have to start with person 1. But usually that first person is randomly selected also. All right, so the bottom 2 sampling methods are both going to use subgroups. All right, so the stratified sample on the bottom left, we call this picking some from all. So what's happening here is the population would be split into subgroups. So maybe it's split by gender or grade. And then they're going to be randomly selected from each subgroup. So again, let's take the Lenape example, right? Natural subgroups in high school would be grades, right? Like freshmen, sophomores, and so on. So if I split by grades, but then I picked 25 students from each grade, right? Then I have kind of a more fair sample of 100 students from Lenape because I evened it out by the grades, right? You're choosing some from all. All right, and then lastly, the cluster sample, we call this choosing all from some. So this time, what we did is we clustered our groups, and then we ended up choosing an entire cluster. So going back to that same Lenape grade example, this would be like each grade being the clusters, right? So 9th grade is one whole cluster group, 10th grade is another. But instead of choosing some from each group, what we would do is just pick some of the big groups. So we might pick just sophomores and seniors and take the entire sophomore class and the entire senior class, right? We would be choosing all of the class from some of the 4 grades. So this one's a little bit less popular, right? Obviously, you're like leaving whole grades out, so it kind of seems like it's going to have some bias. But this one's also used for maybe some like larger populations, like maybe we're doing some work with hospital staff, like in New Jersey, maybe during the pandemic. It might be too costly or time consuming to get, a random sample from all of the 100 hospitals in New Jersey. So you're going to take clusters, right? So you would randomly choose a few hospitals, but you would survey all of the staff at each one of those hospitals. Okay, so now let's practice with a couple of examples where you will have to identify which of these sampling methods were used. Okay, so remember your options are simple random, systematic, stratified, or cluster. Okay, if you chose cluster sampling, you're correct, right? Because we have these 3 lines drawn where they're divided into clusters with those 4 rows, and then that entire top cluster is selected as the sample. Okay, here's the second example. Right, if you chose systematic, you are correct. Right here, every 4th subject is selected. So K is 4. And note that it does not have to start with the first person like it is in this picture, right? Typically, the systematic starts with a random person, and then every 4th would be selected after that. Okay, here's the next example. If you chose a simple random sample, you are correct, right? There's really no rhyme or reason to why these 5 people were selected. So it's probably that they were selected with some type of random generator. All right, here's our last example. Okay, if you chose stratified, you would be correct. Here, each column is like the subgroup, right? And then one member of each subgroup is selected for the sample. It doesn't have to be one from each group, but in this case it was. All right, so I'm going to bring you back here just to remind you that samples are not always perfect representations of the populations from which they're selected, right? Even when the methods on the left here are performed, the probability sampling methods, even when they are performed, right, we're still not going to get perfect. So while the goal is for the sample method to represent the population as closely as possible, that sample is still an estimate. So there's always some error in the results. So now those errors that arise in statistics can be categorized as a sampling error or a non-sampling error. And even though sampling error in blue sounds really bad, it's actually not. Sampling errors are those expected differences between a sample result and the true larger population result. So if we decided to collect data on, say, screen time of Lenape students, right? Each of us in class would collect that data from a random sample of teenagers. We would all get similar results. Well, hopefully, if we chose like our samples correctly, but they would all be a little different because our samples are going to fluctuate, right? The non-sampling errors, on the other hand, are bad in statistics, right? These might have like sloppy data. Maybe you chose a biased sample method. Maybe you recorded data incorrectly. It could also include behavior. So taking into account like if the person was frustrated or angry because of the timing of the survey and how that may have influenced their response. Okay, so I'll leave you with a question to think about that's going to lead into our next class discussion. So how could these other sampling methods, right, the ones in the second column, right? These are the non-probability sampling methods. How could these other methods have errors in the results?